Example 3, we've been through this together, but just to remind you what the values were, this one we did in fractions, but you can change it to decimals if you wish, but be careful that they are recurring decimals. Right, this is where the fun stuff starts. This is something without replacement. So the question that we just did, a marble was taken out, but it was put back. Okay? So that meant that my probabilities on all of my branches remained the same for either marble. These kind of situations are where it does change. Okay? So in some cases, the probability of a second event occurring will change if an item is not replaced after the first event. It may be stated obviously or implied depending on the question. For example, if we're talking about types of chocolate centre, it would be assumed that the chocolate is not replaced having checked the type of centre. So it's not going to say the chocolate is not put back, but you would hope that you would realise that the chocolate wasn't put back. It's like you've got some tins or cans, whatever you call them, you've opened that have no labels, you've opened them up to see what's inside it. You're not going to then be able to put that in back because you've opened it. Yes, does that make sense? So this one here, a bag contains 7 yellow, 3 blue marbles. A marble shown at random from the bag. It's colour noted, it's not replaced. The bag is shaken, the second marble is taken out. Draw a tree diagram. So I've done the bit for you. So we've got yellow or blue are our two options. For our first bead, what's our probability of getting yellow? It's not a trick. 7 out of 10. And blue is 3 out of 10. Now, our bead was taken out. It is not replaced. So how many beads are now left in the bag? 9. So that means that my denominator for each of these has to be 9. And this is how I would suggest that you filled your tree diagram in. Focus on the denominator first. Now, this is where it gets a little tricky and people get a bit confused. If we had followed this branch, it indicates that we had taken a yellow bead, marble, whatever they are, out. How many yellow marbles are now left? 6. So my top number here would be a 6. Because if we followed this branch, we're talking about where we took a yellow one out. Did we take any blue ones out if we followed this one? No. So there are still 3 blue marbles left here for this branch. Now, what is also important is that we know that our two numerators have to add up to give my new denominator. So that's also a help for you. If you're comfortable that following a yellow reduces the yellow by 1, so that's gone down to 6, you know there has to still be 3 blue ones. In a similar way, if we were following the blue marble, then our probability of the blue is now 2 over 9, which means that our yellow would be 7 over 9. Our outcomes are still yellow, 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 blue, blue, yellow, blue, blue. And as I said before, you can work out the probabilities of those events happening before you ask the questions, see the questions, or just when you look at them. So now it says find the probability that both marbles are blue. So you've got to be careful here because you've changed your probability. So this will be 3 over 10 multiplied by 2 over 9 this time. We still are doing top times top, bottom times bottom. So it's 6 over 9. 1 marble of each colour. So we're talking about either of these 2 options. So because it's that option or the second or the third option, we're going to find those probabilities and then add them. Okay, so the first probability would be 7 over 10 multiplied by 3 over 9. The second one would be 3 over 10 multiplied by 7/9. And then we're going to add those two together. To get 42 out of that. Okay, so the method in calculating sums is exactly the same. It's just the fact you have to deal with the fact that the probabilities in the second branch is different. Yeah, as long as you've got a recurring sign on there. Yeah. Yeah, I know. It's just that